Welcome back to NCERT Class 10 chapter number 12 Electricity. Children, in the previous video we learned about resistance means what and resistivity means what, and along with that we have learned certain equations which are based upon resistance and resistivity. So children, in today's class let us solve few numerical problems which are based on particularly resistance. And from the Ohm's law we have derived an equation that V is equals to I into R. Children, you have to remember these formulas because very important. Means this Ohm's law can be written in terms of a current and also in terms of a resistance. That is I is equals to V by R. Means suppose in the question if they have given potential difference value and a resistance, means you have to use this formula. That is I is equals to V by R. Suppose if they have given potential difference and a current value, then you have to use resistance formula. So with these few basic concepts, let us try to solve a numerical problem number 1, children. See, let us read the question. That is, potential difference between 2 points of a wire carrying 2 amperes of current is 0.1 volt. They are clearly telling here, children, the potential difference between the 2 points having a current 2 amperes and potential difference 0.1. Then for such a wire, calculate the resistance between these 2 points. They are asking calculate the resistance. So children, now compare this, which formula we have to use. That is, we want resistance. So what happens? Resistance formula we need to use. Before going to that, let us try to write the given data, children, isn't it? Given data, what they have given, children, that is 2 amperes, nothing but a current value they have given, isn't it? Current, how it is represented? I, which is equals to how much, children? 2 amperes. So shall we write like this? 2A is nothing but a 2 ampere is 0.1 volt. Means the potential difference between those 2 points is how much? 0.1 volt. Means potential difference. How it is represented, children? V is equals to what they have given? 0.1 volt. So what we need to calculate, children? Resistance, isn't it, children? Resistance, R. It is represented by the letter R is how much. So now let us use the formula, isn't it? This formula let us use. That is from Ohm's law. If V is equals to I into R, means this can be written as R is equals to V by I. Isn't it, children? Now substitute the values. Substitute the values, given values we need to substitute in the formula. That is R is equals to V, how much, children? 0.1 volts divided by, what is the I value? 2 amperes. Means let us take it as a 2A. Means R is equals to how much? 0.1 divided by 2. So you can do directly, children. 0.1 divided by 2. You can get nearly 0.05. Or suppose if you feel difficulty, means go by simpler method. This 0.1 can be written as how much, children? 1 divided by 10. So this 1 divided by 10 goes to denominator, means what it becomes? 1 divided by 20, because 10 into 2, 20, children. So 1 divided by 20, if we done calculate, that is 1 divided by, if we done, means smaller is there, so take 0 point, and still smaller is there, let us take one more 0, isn't it? Now 25 is 100. So how we can write this, children? That is R is equals to 0.1 volts divided by 2 amperes. 2 ones are and 0.005. So what is the value, children? 0.05 ohms, isn't it? The SI unit of a resistance is what, children? 0.05 ohms is the resistance across the circuit, which is having a wire which has maintained if 2 amperes of a current across that, such that the voltage supplied is 0.1 volt, means the resistance will be what? 0.05 ohms, children. Understand, children? It's a very simple problem. You have to calculate, use the formula in terms of a resistance and substitute the given data, isn't it, children? Then go for dividing the values. You will get what? Resistance value. Okay, shall we see the next one? More problem, that is a simple electric circuit has a 24 volts battery, means the potential difference here is what? 24 volts, and a resistor of 60 ohms, means the resistance of the resistor, they have mentioned that 60 ohms. So what will be the current in the circuit, and the resistance of the connecting wire is negligible, means very small. What we have to calculate, children? We have to find out the current value. So shall we try, children? Yes. What we have to do at very first step? Given data we have to write, isn't it? What is given? That is potential difference has given. Potential difference. How it is represented? V is equals to 24 volts. Then resistor of having a resistance, how much? Resistance R is equals to 60 ohms. So current I is equals to how much? So what formula we have to use, children? Using from Ohm's law, we can write V is equals to I into R, isn't it? From Ohm's law, what it says, children? V is nothing but that is V is equals to I into R. So what we want to calculate here? I, means we can rewrite this formula in terms of a current I is equals to V by R. So we need to substitute the given values in this formula. That is I is equals to, what is V value, children? 24 volts divided by R value is how much? That is resistance value 60 ohms. Isn't it, children? Now go for calculating this. 6 4s are 24 and 6 10s are, isn't it? 4 divided by 10, nothing but a 10 ones are and 0.4. So what is the unit? Ampere. That is nothing but a 0.4 amperes. So we can write that I is equals to 0.4 amperes is the current drawn across this circuit, isn't it, children? This is also very simple. Only the thing is that what they have given, you have to collect it at first, means you have to write it at the very first step. After that you have to use the Ohm's law, means equation V is equals to I into R you have to write, and in terms of a current we can rewrite that. Then we have to substitute the given values. So finally we will get the value of a current in that is which is equals to 0.4 amperes. Understood, children? Children, an electric iron draws a current of 3.4 amperes from the 220 volts supply line. What current will this electric iron draw when connected to 110 volts supply line? Here in this question it consists of two steps, children, means it's like a sub question. It consists of two sub questions here, we can say, because we have to calculate that is electric iron when it is connected to 220 volts. Similarly, in the same electric iron when it has connected to 110 volts also we need to calculate. So it consists of two parts, children. So let us first find out. See here, what are the given data, children? That is current value, that is 3.4 amperes they have given, and what is the potential difference value? 220 volts. So we need to calculate what? First, resistance, isn't it? Given, that is electric iron when connected to 220 volts, isn't it, children? That is what? Current I is equals to 3.4 amperes, and potential difference V is equals to 220 volts, isn't it? Now use Ohm's law, children. Ohm's law, that is V is equals to I into R. So substitute these values, children. That is, we want to calculate R, no here? Yes. Resistance we need to calculate. So in terms of a resistance, how can we write this, children? R is equals to V by I. Now what we have to do? We have to substitute the given values in this. This implies R is equals to V is how much, children? 220 volts divided by I is how much? 3.4 amperes, isn't it, children? Now if we, that is R is equals to 220 divided by, that is 34 divided by 10, isn't it? Which is nothing but a 220 into 10 divided by 34, isn't it? So what is the next value, children? Which is nothing but a 2200 divided by 34, isn't it? So that is 2 ones are, isn't it? 2 sevens are, 2 ones are and 00. Now calculate this. 1100 divided by 17, isn't it, children? That is 1100. Here 110 means 6 it can go, children, because S 102, isn't it? 8 has remained and 0. Now 17 4 we can divide that, isn't it? Then 1 and 2. If we keep point means here it becomes 120. Then 7 isn't it, children? Like that it will continues. What we will get, children, if we divide 1100 divided by 17 is nothing but a R is equals to what? 64.7 is the resistance. 64.7 ohms is the resistance when an electric iron is connected to 220 volts supply. Suppose if the same electric iron it has connected to 110 volts, then what is the current across it? We have to calculate. Means use this resistance value, isn't it, children? Then we will get a what? Current value. That is when it is connected to 110 volts supply, then what is that? V will becomes 110 volts. R is equals to 64.7 ohms and I is equals to how much is our question, isn't it, children? So again use the same formula, but in terms of a current you have to take, that is I is equals to V by R formula you have to use, children, isn't it? Now substitute the values, that is I is equals to V means here Now it has supplied 110 volts supply. So 110 volts divided by 64.7 ohms. Okay children, when you make cancellation this, you will get nearly 1.7 amperes. That is, I is equals to 1.7 amperes of a current you will obtain. Okay children, shall we see this once? That is 1100, that is better here we will do rough work. That is how much? 110 divided by 64.7, isn't it children? So now 64.7 can be written as a 647 divided by 10. That denominator goes to numerator means how much it becomes? 1100. That is divided by 647. Now 647 1 and 647 1, isn't it children? Now and again 7 ja, isn't it children? So the same value we have obtained, I is equals to how much? 1.7 ampere. So it's clearly saying children, when the voltage is more, the current also it won't increase. It around we will get a 3.4 amperes of a current. Suppose if the potential difference means the voltage has reduced, means decreased to 110 volts, means the similarly what happens? The current value also going to be reduced. Got it children? Children, up to now we have discussed problems about resistance. But now let us try to solve problems based on resistivity. Isn't it children? We learned that resistivity is nothing but it's a characteristic property of a material. And the formula for it is what? Resistivity. Rho is equals to R into A divided by L children. So using these formulas, let us solve few numericals children. That is question number 1. A copper wire of length 2 meter and area of cross section 1.7 into 10 to the power of minus 6 meter square has a resistance of 2 into 10 to the power of minus 2 ohms children. For such a thing, we need to calculate the resistivity of copper. So children, let us make some assumptions. If this is a copper wire, isn't it children? The length of it is how much? 2 meter. And it have a area of a cross section how much? A is equals to, this is means area of a cross section is how much? 1.7 into 10 to the power of minus 6. The unit of a area children? Meter square or square meter you can say. Okay, no problem. Now resistance is how much? R is equals to 2 into 10 to the power of minus 2 ohms. And resistivity is what we need to calculate. So children, let us start solving that. That is given data. What they have given children? Length L is equals to 2 meter. Then area of cross section A is equals to 1.7 into 10 to the power of minus 6 meter square. Isn't it children? Now, then resistance R is equals to 2 into 10 to the power of minus 2 ohms. We need to calculate its resistivity. That is how represented children? Rho is equals to how much? So in terms of a resistivity, what is the formula? Rho is equals to R into A divided by L. So using formula, we can write resistivity is equals to R into A divided by L. What is the unit of resistivity children? Very good. That is what? Ohmmeter. Isn't it children? Now substitute the values children. Substitute the given values isn't it, children? What we'll get? Rho is equals to, or is how much, children? 2 into 10 to the power of minus 2 ohms. Into A is there. Into, what is A value? 1.7 into 10 to the power of minus 6 meter square, divided by L value is how much, children? 2 meter. Isn't it, children? This is what, after the substituting values, we will get this. So now do cancellation. 2 ones are 2 ones are. What has remained, children? 1.7 into 10 to the power of minus 6 and into 10 to the power of minus 2. If exponents, isn't it, or on the numerators, means what we will do? We will go for adding that. Minus 2 into minus 6, what it becomes? Minus 2 into minus 6, minus 7, sorry, minus 8, isn't it, children? So rho is equals to 1.7 into 10 to the power of minus 8 ohmmeter, isn't it? That is how means we can do rough work here. Minus 2 into 10 to the power of minus 6, which can be written as 10 to the power of minus 8, isn't it, children? So the resistivity of the copper wire, therefore we can write resistivity of copper wire is 1.7 into 10 to the power of minus 8 ohmmeter. Got it, children? It's a very simple problem, and this based upon the resistivity. Recently they have asked a question in the board exam, children, so practice problems many. Children, now let us solve one more problem, that is based on resistivity. A copper wire has a diameter 0.5 millimeter and resistivity 1.6 into 10 to the power of minus 8 ohmmeter. What will be the length of this wire to make its resistance such that it should have a 10 ohms? How much does the resistance change if the diameter is double? It also consists of what? Two parts, children. First, we need to calculate what is the length of the wire by using there is diameter value and a resistivity value. So, children, first let us write the given data, children. What they have given? Diameter means nothing but here length, diameter thickness, isn't it, children? 0.5 mm. See, children, millimeter, as I already said, it is nothing but a 10 to the power of minus 3 meter, isn't it? Milli means 10 to the power of minus 3. So next is what? Resistivity. Rho is equals to how much? 1.6 into 10 to the power of minus 8 ohmmeter, isn't it, children? Now what we need to calculate, and that is resistance also given, isn't it, children? Resistance R is equals to 10 ohms. Then length of the wire L we need to calculate, isn't it, children? So see, children, whenever they have given diameter means you have to take it in terms of that is radius, because A is nothing but a, that is area of a cross section, which is equals to pi r square, isn't it, children? So we will write this in terms of what? Radius. We learned that diameter D is nothing but a half of the diameter is nothing but a radius, isn't it, children? D by 2 is one radius, isn't it, children? Diameter is nothing but a that is in order to in the form of a radius. How we can write that? That is when we divide into two equal parts, we will get a radius value. So now area of cross section. A is equals to pi r square. So pi value is, children, 22 by 7, or you can write 3.142. One and both same, isn't it, children? Better I'll write 3.142 into r. R is nothing but here d by 2. D by 2 whole square, because radius square is there. So r is nothing but a d by 2. We have to write in term of a exponent, that is square. So we can write that 3.142 into, what is the d value, children? 0.5 into 10 to the power of minus 3 divided by 2 whole square. So this can be written as 3.142 into 0.5 whole square means 0.25 into 10 to the power of minus 3 into 2, 10 to the power of minus 6, isn't it? Denominator also square, 2 square means 4 is the cross-sectional value, isn't it, children? What is the unit of area of cross section? Meter square. Now this A we have to substitute in the resistivity formula, isn't it, children? What is that? R is nothing but a rho into L by A, isn't it, children? What we need to calculate? L. Then how we can rewrite this? L is nothing but a R into A divided by rho. This formula we have to use. Now we will substitute the given values in this formula, children. That is, this implies L is equals to, what is the R value? 10 ohms. Then A is how much? Into 3.142 into 0.25 into 10 to the power of minus 6, isn't it, children? Divided by 4. Divided by 4. This is all what? One term, isn't it, children? Divided by, now what is the rho value? 1.6 into 10 to the power of minus 8 ohmmeter, isn't it? Now this, if this denominator goes to down, numerator means what will remain, children? That is 10 into 3.142 into 0.25 into 10 to the power of minus 6 divided by 4 into 10 to the power of, 1.6 into 10 to the power of minus 8 has left, children. Now first you do multiplication of this and this, isn't it, children? What you will get? 31.42 and divided by what? 6.4 into 0.25 into 10 to the power of minus 6 and 10 to the power of minus 8. And here 10 to the power of minus 2 will remains, and this is 1, isn't it? If it goes to numerator, 100 it will become, and here you will get 6.4. That is how much? 31.42 into 0.25 into 100 divided by 6.4. If you done this, means you will get L is equals to 122.7 meter. So how much, children? 122.7 meter is the L value, means length of the wire is how much? 122.7 meter. Now what is the next part, children? How much does the resistance change if the diameter gets doubled, isn't it, children? In the theory class we learned that if that is, yes, better I'll write here, if R is inversely proportional to square of the diameter, isn't it, children? This we have learned in our previous class, isn't it? Because sometimes thickness is also represented using diameter. So R is inversely proportional to square of the diameter. Now what it tells children, if D is becomes twice, that is R is inversely proportional to how much, which is nothing but equals to 1 by 4th times. So if the diameter is doubled, the resistance will reduce to what, 1 by 4th time. Isn't it children? Yes, that's why children I have explained, that is while explaining the factors affecting, clearly I have explained about this, isn't it children? Suppose if diameter has doubled, or suppose if it has tripled, or if it has reduced to half, what will be its that is resistance, isn't it children? So if diameter gets doubled means we have to make it as a 2, that is 2 square is nothing but a 1 by 4th. So resistance is going to reduce to 1 by 4th time. Got it children? Yes, this is a little bit complicated, but don't keep that in mind children. Try to practice. Definitely you will success in solving this problem. That is a 6 ohm resistance wire is doubled up by folding. Calculate the new resistance of the wire. See children, they are saying that if the resistance of the wire is 6 ohms, isn't it? If it has made doubled, then calculate the new resistance of the wire they have asked, isn't it children? So suppose if R is equals to rho into L by A, what is the value of resistance here? 6 is equals to rho into length divided by A. This is what? Say equation 1. And see children, R is equals to 6 ohms when that is having a length L and area of a cross section A, isn't it children? When it have a area of cross section A, the resistance of the wire is this much children. Now the new wire, suppose the new wire is, if the wire is doubled up by folding, doubled up by folding means length L will becomes L by 2 and cross section will increases by 2 times, isn't it children? That is we have to use now these values. Now substitute again these in the first formula, that is R is equals to rho into L divided by A, isn't it children? We need to calculate R here, isn't it? So keep as it is, and rho also keep as it is. And what is the new length value? L by 2 divided by, what is the cross sectional? That is 2A. This can be written as rho into length divided by, goes to denominator means 2 into 2, 4A. So we can write that R is equals to rho into L divided by 4A is the second equation. Now divide children equation 2 by equation 1. Divide equation 2 by 1, isn't it? R by 6 is equals to, because here 6 is there. Next, rho into length divided by 4A and whole divided by what? This value, that is rho length and divided by A children. So here this rho and L will get cancelled, here also get cancelled, and this A cancels and this A also cancels. So what has remained children? 1 by 4 means R by 6 is equals to 1 by 4, isn't it children? Now this go cross multiply done means R is equals to, what is that children? 6 by 4. 4 ones are, sorry, 2s are, then 3s are, then 2 ones are, and 2 ones are, and 1 has remained, 2 fives are. So what is that? R is equals to 1.5 ohms is the new resistance, children. See, it clearly saying that initially if the length of the wire is L and the area of a cross section A is this much and its resistance will be 6 ohms. Suppose if the wire got doubled, means it has doubled, means here it is folded up by doubling, then we will get a new resistance, and we have to calculate that. That is by taking, when we are folding it, means we will get a length will be reduced to half. So the new length of the wire is L by 2 we have to take, and similarly the area of the cross section, isn't it, it increases by 2 times. So 2a you have to take and divide equation 2 by equation 1, isn't it children? We will get a new resistance value. So children, these are a few problems which are based on a resistivity. Practice thoroughly children. If you have any doubts, you can contact me.